Hello everyone. In today's lecture, we are going to discuss a case study. So, let us discuss a case study on LED blinking using a PIC16F877. In order to interface this PIC16F877 and to implement it, I'm going to use the PIC kit which is offered by VI Micros, and for that I'm going to use the Integrated Development Environment MPLab IDE. So let us look into how to work with MPLab IDE and how to implement it using PIC16F877. So first we need to install MPLab IDE in our system. So this is very easy to install, and so first initially double click the MPLab IDE shortcut icon. You will enter into MPLab IDE like this. So once after MPLab IDE is open, so this is a compiler for running this using this PIC16 means C embedded C programming for PIC16F877. So then once if it open, we have to click the project wizard and then click next. Since the kit which I am going to use is PIC16F877A, I am choosing a PIC16F877A, and I am going to use the CCS compiler to compile the embedded C code which we are going to choose. And so use CCS compiler, then create a new project. We can have a new folder if required, and then inside the new folder create a file name. Whatever file name we need to give, we can give the file name. So let us include that and then click next and then finish. So we have created a project. Now once after creating the project, we have to include the source file which we need to. So already I have typed the source code in a notepad. I am using it here. So this is for blinking an LED. So this is the source code which I am using. So in this source code, if you see, I've initialized all the basic initializations required. The header file for PIC16F877A is included. The clocks, the baud rate, and all the basic initializations has been done. And here below comes the program. So it is like initially I have 8 LEDs and all the 8 LEDs will be blinking, and then the LEDs will be first initially all the LEDs will be blinking, and then one by one first LED, second LED, third LED, fourth LED, and so on will be blinking, and then again all the LEDs starts to blink. So this becomes an iterative loop, and so I have given an while of one loop. So this is how the code works, to blink all the LEDs, and then one by one all the LEDs will be blinking. This is a case code for which I have written. So now after completing the code, we have typing the code, we have to save the file. Save the file with an extension .c. That is very important. So already we have created a file, and now this source code has to be saved with an extension .c. So .c is must, and then save the file. Once after saving the file, already we have created a project, and it is required to add this file into that project. So go to the project, then add files to project. Here we have the LED blinker. So include the file, and we can see that that C file has been included in the project. Now we have to build it. So after when we are building, the compilation on all the process will be taking place. Also a hex file will be generated once after building. If we have any errors or warnings, will be displayed here. So if there is no errors and warnings, our build will be succeeded. If you have any errors or warnings, build will fail. Now we have compiled the program, and now it's time to download it to the kit. So for that I am using boot plus loader. So in PIC boot plus loader, the file which we have already done is LED blinker, and select the file LED blinker.hex. So once we are building, we'll be having this .x file, so that has to be included. Select the communication port whichever is applicable for your system. For me it is communication port 1, since I am connecting it through a cable. Then we have to make sure that the code is in program mode, and then the switches are in program mode and external modes in the kit. After that you press the reset button, then hold on the reset button and click the write. So the program will be returned onto the computer. PIC16F877A kit. So here we can see how to download it to the PIC kit using PIC boot plus loader. Once after build is